Jai Hind. My name is Dr. Sunil Kumar, and in this lecture I am going to discuss very important topic, one of the most popular sorting technique, that is quick sort. In this lecture I am going to discuss the sorting technique. That is quick sort. As the name suggests, it sorts the given numbers very quickly. First thing. The second thing we can say, quick sort is not a stable sorting technique, but it takes very less time and very less additional space for sorting the given numbers. This sorting technique is based on a rule that is divide and conquer. The meaning is that we divide the main problem into sub-problems, sub-problems into further sub-problems, and we apply the quick sort onto the each part. It is also known as exchange partition sort. This is the another name of quick sort. Now, quick sort algorithm divides the given list into three parts. The first part, elements less than the pivot element. Then what is pivot element? In the given list, any element can be the pivot element, that can be the last element, that can be the first element, or that can be any element. The second part that we are discussing, that is called pivot element. And as discussed, it can be the last element, it can be the first element, or it can be any element. And the third part, elements greater than or equal to pivot element. The three parts this algorithm do. It is like that. For example, this is the given list, and for example, it is P the pivot element. Then in this case, this part will contain elements less than the pivot element. And this part, elements greater than or equal to pivot element. And after single pass, the location, or you can say position of the pivot element is fixed. Let us take an example. for example, we have given these numbers. For example, we have given 3, we have given 7, 8, 4, 2, 1 and 5. And we have to sort these given numbers by quick sort. If we are doing the indexing, then this is the lower bound, and for example, we are representing this with P and the last element with R. If I am putting all the elements in an array, and if I'm doing the indexing from 1, 2, 3, 4, 5, 6 and 7. Then in that case, the value of P is 1, that is lower bound value, and value of R is 7. Now, as I told, out of the given elements, we have to select one element as a pivot element. For example, first of all, we are discussing by taking the last element as a pivot element. Now, for example, I am running a loop with the help of J. So that is jth index element, and just one element ago, I am taking I. Means I is j minus 1. Now, what we have to do in the quick sort, always we have to compare jth index element with the chosen pivot element. In this case, it is 5. Now, if I'm comparing 3 with 5, then 3 is less than 5. Then in that case, if this element, again, this element is less than or equal to pivot element, then we have to increase the value of I. You can write down like this: if A of j is less than equal to pivot element, then we have to increase I equal to I plus 1, and we have to exchange the value of AI with AJ. In the first case, 3 is less than 5, then I will increase I by 1 and I will exchange the value of I and j. In this case, value of AI is 3, value of AJ is 3, that means 3 is replaced with 3. Then after that, we have to increase the value of j. In that case, j will come here. Again, हमें करना क्या है कि हमें jth index को compare करना है pivot element से. 7 is greater than 5, then in that case, simply j equal to j plus 1. Again, jth index element is compared with the pivot element. 8 is compared with 5. 8 is greater than 5. Then simply we have to increase j by 1. Again, j plus 1. Sorry. In this case, 4 is less than 5. Then in that case, we are here. In that case, 4 is less than 5. Then simply we have to increase I by I plus 1 and we have to exchange the value of I and j. तो यहाँ पे हम इन दोनों की वैल्यू को एक्सचेंज करेंगे, ठीक है. तो दैट इज 3, दैट इज 4, 8, 7, 2, 1 and 5. नाउ आफ्टर दिस, जो मेरा I है वो यहाँ पे है और मेरा जो J है वो इस इंडेक्स पे है. अगेन J इक्वल टू J प्लस 1. Again 2 is less than 5, तो मुझे क्या करना है, i इक्वल टू आई प्लस वन और ए आई और ए जे की वैल्यू को आपस में इंटरचेंज करना है. तो दैट इज 3, 4, 2, 7, 8, 1 एंड 5. तो अभी मेरा j यहाँ पे है और i मेरा यहाँ पे है. ठीक है. देन अगेन j इक्वल टू j प्लस वन. अगेन 1 इज लेस देन 5. तो मुझे क्या करना है, i को i प्लस वन एंड आई हैव टू चेंज द वैल्यू ऑफ i and j. इट विल बी 3, 4, 2, 1, 8, 7 and 5. Now j is here and I is here. जब हम पाइवेट से पहले तक j का इंडेक्स पहुंच जाएगा, जस्ट पाइवेट से फर्स्ट, दैट इज अप टू r माइनस वन. एट द लास्ट स्टेप व्हाट वी हैव टू डू, i को इंक्रीमेंट करके एट द लास्ट स्टेप हमें उसको पाइवेट एलिमेंट के साथ एक्सचेंज करना है. तो इन दैट केस इट विल बी 3, 4, 2, 1. It will be 5, it will be 7 and it will be 8. So now we can check, this is our pivot element and all the elements before this are less than the pivot element and all the elements after the pivot element are the greater than the pivot element. Now the value of pivot element is fixed, but still elements are not sorted. We will apply the same process on the list 1 and on the list 2. So let us start. Now in this case, list 1 containing 3, 4, 2 and 1. Now process will be same. I have taken the last element as a pivot element. The first element I have taken as a j and just one element before I have taken I. That is I equal to j minus 1. Now again, always jth index element is compared with pivot element. 3 is greater than 1, then simply we have to do j equal to j plus 1. Again 4 is greater than 1, j equal to j plus 1. 2 is greater than 1, that means now I am reached out just before one element of the pivot element. At the last step, what we have to do, we have to increase I and we have to exchange it with the pivot element. Then in that case, it will be 1, it will be 4, it will be 2 and it will be 3. Now we can check, this is our pivot element, which position is fixed and there is no element before 1 and all the elements after this are greater than the pivot element. Now we will apply the same process on this number. Now we have 4, 2 and 3. We have taken the last element as a pivot element and this is our jth element just before I, one position before. Again we are comparing 4 with 3. 4 is greater than 3, then simply j equal to j plus 1. Now in this case 2 is less than 3, then in that case we have to increase I and we have to exchange the value of I and j. That is 2, 4 and 3. Now here that is right now it is j and it is I. At the last step, what we have to do, increase I by I plus 1 and we have to exchange with the pivot element. So that is 2, that is 3 and that is 4. Now we can check, In this case, 3 is the pivot element, and all the elements before the pivot element are lesser than the pivot element, and 4 is greater than the pivot element. Now the same process will be followed on these two numbers, that is 7, 8. We can do this side. Already sorted, but we will repeat the process. Again, we have taken the last element as a pivot element. This is j, or just एक position पहले I, that is I equal to j minus 1. We are comparing 7 with 8. 7 is less than 8, then I equal to I plus 1, and exchange the value of I and j. In this case, the value of I and j same, then 7 is replaced with 7. At the last step, we have to increase by 1, that is I, and we have to replace with the pivot element. That means 8 is replaced with 8. That is 7, 8. Then we can check all the elements before the pivot element are lesser, and there is no element after the pivot element. Now, in that way, we can sort all the elements. Now, we'll discuss about the algorithm part. That is quick sort algorithm. Now, capital A means array, P is the lower bound of the array, and R is the upper bound of the array. Okay. Now, in the first step, we will do the partition, and first of all, we are doing the partition, and for example, partition that is Q, and we are doing A, P and R. And after the partition, we will apply the quick sort on A, P, that is Q minus 1. Why are saying so? Suppose we are taking, this is the lower bound, this is Q, and this is R. So just before one position, it is P2 Q minus 1, that is Q, and after that Q plus 1 to R. So we will apply the sorting on this sublist and on this sublist. So that is A, that is array P2 Q minus 1, and quick sort array Q plus 1 to R. Okay. Now, first of all, we have to partition at this step. It will call for the partition. So just I'm writing the steps. Partition, that's we are doing A for array, P is the lower bound of the array, and R is the upper bound of the array. Now, according to this sorting technique, what we have done, we have taken the last element as a pivot element. For example, that is X. So X equal to, that is A of R. X is the pivot element, and R is the upper bound of the array, A is the array, and we have taken that element as a pivot element. In the second step, what we have done, I equal to j minus 1. तो जस्ट वी हैव डिस्कस कि j से जस्ट एक पोजीशन पहले हमें एक वेरिएबल i लेना है, एंड द वैल्यू ऑफ i इक्वल टू j माइनस 1. देन आफ्टर दैट हम एक लूप चलाएंगे, दैट इज फॉर लूप फॉर j, और j की रेंज क्या होगी, j इक्वल टू p2 r माइनस 1. p इज द लोअर बाउंड, और ये हमें जस्ट पाइवेट से पहले एक पहले एलिमेंट तक चलाना है. उसके बाद हमने क्या किया, इफ ए ऑफ जे, यानी जे जो इंडेक्स एलिमेंट है इज लेस देन इक्वल टू एक्स, क्योंकि हम उसे पाइवेट एलिमेंट से कंपेयर कर रहे हैं, देन हमें क्या करना था, देन हमने क्या किया था, आई इक्वल टू आई प्लस 1, आई को इंक्रीमेंट किया था एंड उसके बाद एक्सचेंज ए ऑफ आई विद ए ऑफ जी, और ये हमारा कब तक रन करेगा, पी से लेके r माइनस 1 तक। और लास्ट स्टेप में हमने क्या किया कि जब हमारा jth इंडेक्स पाइवेट से जस्ट पहले तक पहुंच जाएगा, देन वी आर डूइंग एक्सचेंज ए आई प्लस 1 with a of r. That means we are changing with the pivot element. And finally, we are returning return I plus 1. Again, we can discuss. We are writing the sorting algorithm for quick sort. A is the array, P is the lower bound of the array and R is the upper bound of the array. Now, first of all, because it is based on the divide and conquer, we are dividing the complete list into the further sublist. That is, we are doing the partition. And for example, after partition, we are doing partition from P to Q and Q plus 1 to R. And in that case, A is the array, P is the lower bound and R is the upper bound. After partition, the list will be, first sublist will be P to Q minus 1 and second sublist will be the Q plus 1 to R. Now, when we will run this algorithm, first of all, we have to do the partition. It will come here. That means we are doing the partition. A is the array, P is the lower bound of the array and R is the upper bound. So, first of all, as we have discussed, we have taken the last element as a pivot element. Okay, we have taken a variable I and I means G minus 1. ठीक है, जो अरे के इंडेक्स को वी आर रिप्रेजेंटिंग विद द जे प्लस 1 अप टू r माइनस 1. उसके बाद हमने एक लूप चलाया जे के थ्रू, दैट इज p टू r माइनस 1, पाइवेट से जस्ट पहले तक. और उसमें हम क्या कर रहे हैं कि jth इंडेक्स वाले एलिमेंट को वी आर कंपेयरिंग विद द पाइवेट एलिमेंट. अगर jth इंडेक्स वाला एलिमेंट पाइवेट एलिमेंट के बराबर है या उससे छोटा है तो हमें क्या करना था, i इक्वल टू i प्लस 1, और उसके बाद वी हैव टू एक्सचेंज द वैल्यू ऑफ ए आई एंड ए जे. ये कब तक चलेगा हमारा, पाइवेट से जस्ट पहले तक. एंड एट द लास्ट स्टेप व्हाट वी हैव टू डू, वी हैव टू एक्सचेंज आई को हमें इंक्रीमेंट करके इसको पाइवेट एलिमेंट के साथ हमें एक्सचेंज करना है. एंड फाइनली इट विल रिटर्न I plus 1. So this is the algorithm when we are taking the last element as a pivot element. Now, as I discussed, any element can be the pivot element. We have discussed the last element as a pivot element. Now, for example, we are taking 3, 7, 8, 4, 2, 1, 5. Now, this time I am taking the first element as a pivot element. Sometimes in the exam question comes, you have to sort the given elements by using quick sort by taking the first element as a pivot element. Now, in this case, how sorting will be done by the quick sort? For example, this is I and this is J. Now, we will move I from left to right and we will stop I when ith index element is greater than the pivot element. जब हम J को चेक करेंगे, we will move from right to left और उसको हम कब स्टॉप करेंगे, जब वो पाइवेट से छोटा एलिमेंट हमें मिल जाए. तो जैसे मैंने 7 को 3 से कंपेयर किया, पहली बार में ही आई की वैल्यू 5/8 से बड़ी है, तो मैंने इसको यहीं पे फिक्स कर दिया। दैट मीन्स ये अपनी राइट पोजीशन पे। फिर मैंने जे को चेक करना शुरू किया, 5 इज ग्रेटर देन 3। देन मैंने नेक्स्ट एलिमेंट पे मैं स्विच कर गया, 1 इज लेस देन 3, क्योंकि इधर हमें लेसर देखना है, तो मेरा जो जीएथ एलिमेंट है वो यहाँ पे जाके स्टॉप हो जाएगा। ओके, उसके बाद हमें क्या करना है, आई और जे की वैल्यू को आपस में इंटरचेंज करना है। तो जब हम इंटरचेंज करेंगे, इट विल बी लाइक दिस, 3 दैट इज 1 8 4 2 7 एंड 5। ओके, तो अभी मेरा ये आई था और ये मेरा जे था। अगेन द सेम प्रोसेस विल बी फॉलोड। मैं आई को इंक्रीज करूंगा और मुझे हमेशा उसको पाइवेट से कंपेयर करना है और मुझे बिगर नंबर देखना है। तो जैसे मैंने आई को इंक्रीमेंट किया, तो 8 इज ग्रेटर देन 3, दैट मीन्स आई मेरा यहाँ पे शिफ्ट हो गया एंड इट विल स्टॉप हियर। इन द सेम वे मैं जे को इंक्रीमेंट करूंगा, तो जे मेरा यहाँ पे आया एंड जे इज लेस देन 2 इज लेस देन 3, तो जे मेरा यहीं पे स्टॉप हो जाएगा। उसके बाद हमें क्या करना, इन दोनों की वैल्यू को आपस में इंटरचेंज करना है। तो इट विल बी 3 1 2 4 8 7 and 5. Okay, so right now it is J, it is I. Again we will do the same process. I को मैंने इंक्रीज किया, 4 को कंपेयर किया 3 से, तो 4 हमारा 3 से बड़ा है, तो हमारा I जो है यहीं पे स्टॉप हो जाएगा। देन अब हम कंपेयर कर रहे हैं इसको, J को मैंने इससे कंपेयर किया 3 से, 8 जो है बड़ा है, तो मेरा आपका J यहीं पे स्टॉप हो जाएगा। तो मैं इन दोनों को आपस में एक्सचेंज करूंगा, दैट इज 3 1 2 8 4 7 and 5. So that is our J और that is our I. Again आपने I को इंक्रीज किया, तो that is 4, तो ये मेरा आपका I यहाँ पे शिफ्ट हो गया। इधर चेक करेंगे तो J मेरा यहाँ शिफ्ट हो गया। 8 इज ग्रेटर देन 3, तो ये जब दोनों एक दूसरे को क्रॉस कर जाएंगे, तो मैं क्या करूँगा, जब दोनों को क्रॉस कर जाएंगे तो मुझे इसको पाइवेट के साथ इंटरचेंज करना होगा। तो इन दैट केस पाइवेट जो है वो फिक्स हो जाएगा एंड उससे पहले सारे एलिमेंट जो है पाइवेट से छोटे होंगे और उसके बाद सारे एलिमेंट पाइवेट से बड़े होंगे। तो इन दैट वे वी कैन रिपीट दिस प्रोसेस। थैंक यू।